Good morning, children.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Children, I'll just take you through a few slides from real numbers. Just have a look at it because I don't think you have to work them. I'll just, give you a minute's time to go through every slide. So see this one. I'm sure you know this. If you have any question, you can ask me. Using FTA, meaning using the fundamental theorem of arithmetic, that is by the prime factorization method. So you see that in the first column. We express every number as a product of its primes, and then we find the HCF. To find the HCF, you need to write out the common factors raised to the least power, only the common factors, not all the factors. To find the HCF, write out the common factors once. So 2 and 23 common, write it once with the least power. Least power. Using EDA, meaning Euclid's division algorithm or Euclid's division lemma. So for that, you can see the division alongside, and the HCF is 46. Fundamental theorem of arithmetic means the prime factorization method. For LCM, you will write all the factors. All the factors, you will write them once and raise them to the highest power and find that product. Express the HCF of these two numbers as a linear combination of the two given numbers. You want to try this now, children? Yeah, I think that linear combination you have to try. We'll work this now, children. Please work. What's the HCF, children?
$23, ma'am.
23. Very good. Now we'll do that linear combination together, okay? We'll do that linear combination together. Okay. So you need to first start with the HCF and use the division algorithm. Use the division algorithm. Start with the HCF. What is the HCF? HCF is 23. The HCF is 23. Okay. We start with the HCF. Okay. So the HCF, let's do it here. Tell me the division, children. 575, 1288. Tell me the division.
Ma'am, 2,
2,
1150,
1150. Remainder,
138.
138. How many times?
4 times.
How many times?
4 times.
Okay. Product,
552,
remainder,
23.
how many times?
6 times.
Okay. Okay, so we start with the HCF. Now, how can you express the HCF is 23. So how can you express 23? The HCF 23 is equal to yes, children, the HCF 23 is equal to. So we know that the remainder is equal to dividend minus divisor into quotient. Okay, what's the division algorithm? Dividend is equal to divisor into quotient plus the remainder. This is the division algorithm. Dividend is equal to divisor into quotient plus the remainder. So now the HCF is the remainder actually. So what is the remainder equal to? Dividend minus divisor into quotient. This is the division algorithm. Dividend is equal to divisor into quotient plus the remainder. So the remainder is equal to dividend minus divisor into quotient. So we are going to use this because 23 is the remainder. The HCF 23 is the remainder. Okay. Yes, children. So 23. At which stage is it the remainder? It's the remainder here. So the corresponding dividend is this one, divisor and quotient. So the remainder 23 is equal to the dividend 575 minus the divisor 138 into the quotient 4. Am I right, children? Okay, no time to waste. Now, again, continue. 23 is equal to 575. Keep replacing the remainders. Now here, 575, 138, 4, which is the remainder? Before 23, which is the remainder? 138. So you need to replace 138 using the same rule, dividend minus divisor into quotient. So write this minus sign as it is. Now for 138, I'm using this bracket into 4 outside. Into 4 outside. Now 138 is going to be replaced with the rule dividend. Which is the dividend, children? Kindly answer. If 138 is a remainder, tell me the corresponding dividend, divisor and quotient. No, if I'm not clear, I'll come from the beginning, children. Tell me something. Am I audible?
Yes, ma'am.
Yeah. No. Is it not clear? Shall I come from the beginning, children?
I just didn't understand the question you asked, ma'am.
Sorry?
I just didn't understand the question you asked.
Oh, very good, very good. Okay, now you'll understand when we finished. Okay, fine. 1 minute. You understood what I said, Kanishka? Remainder is equal to dividend minus
Yes, ma'am,
divised into.
and I understand what you said, but I just didn't hear what you said. The question
Oh,
clearly.
you don't know my question. Okay, okay, fine. Let me start again. This is the remainder, correct? Remainder. So by the rule, the corresponding dividend is 575, correct? Minus divised into quotient. This step, all of you understand?
Yes, ma'am.
Okay, now continue. 23 is equal to, replace the remainder. See, among the numbers 575, 138 and 4, this is the remainder. So now replace that. See here, 138 is a remainder. 23, 0, 23 and 138 are the remainders. Now replace the remainder 138. So write this 575 as it is, minus sign as it is. This is for 138 into 4. Now what is 138? Its dividend is 1288. Dividend minus divisor into quotient minus 575 into 2. Now that's all we have done, because we have replaced every remainder. That's all. When will this process come to an end? When you've replaced all the remainders. Now that's all. Prior to 138, there is no remainder. There are only 2 remainders here. And for both the remainders, we've used the rule. So that's it. Now you just have to simplify this. Is equal to 575 minus, multiply this, 1288 into 4. Is 1288 into 4. Minus into minus plus, right? 575 as it is. This, see, now in 575 into 2, the quotient is 2. You should multiply 4 with the quotient 2, not with 575. See, you'll have to multiply. You should find this product 575 into 2 into 4. Now, should you multiply 4 with 575 or 4 with 2? You should multiply 4 with 2 because 2 is the 2 is the quotient. Multiply 4 with 2, not with 575. So it will be 575 into 2 4s are 8. Now you need to simplify. So 23 is equal to 575. You can write as 575 into 1. 575 means 575 into 1 minus 1288 into 4 plus 575 into 8. Now, like you simplify the like terms, 575 once, 575 8 times. So that is, we have 575 9 times. 9 times minus 1288 into 4. Normally, we want a positive sign in the middle. So 23 is equal to 575 into 9 plus 1288 into minus 4. So you can see in the last step, we have expressed the HCF 23. We have expressed the HCF 23 as a linear combination. What is a linear combination? A linear expression. So what is a linear expression? 575 into X plus 1288 into Y. You can use X and Y or A and B, M and N, whatever, where X is 9 and Y is minus 4. So you can see the last step, the HCF 23 is equal to 575 into X. X means X power 1, linear combination, into 1288 into Y. So that 575 into X plus 1288 into Y is the linear combination of the given numbers 1288 and 575. See the question, express the HCF. So last step you can see we have expressed the HCF. 23 is equal to. So we have expressed the HCF as a linear combination of the given numbers. So you can see how we have expressed it. 575 into X plus 1288 into Y. It's a linear combination in X and Y. Am I clear, children?
Yes, ma'am.
Yeah, please do this. All of you, please work this in your book. Take the question and work this in your book. Done, children?
One minute, ma'am.
Okay, okay. No hurry, yeah.
Completed, ma'am.
Good. Yeah. See this? If the HCF of these two numbers is expressible in this form, then find the value of M. So here what you have to do is, you have to first find the HCF of 408 and 1032. Because it's given that the HCF can be expressed like in the form 1032M minus 408 into 5. It's very simple. Just find the HCF of the two numbers. Just find the HCF of the two numbers. So you can see here. I performed this division, and the HCF of the two numbers is 24. Is 24. It's given that the two numbers can be expressed in this form. That means 24 can, the HCF 24 can be written like this. That's what is given. See the question given. The HCF of these two numbers can be written in this form. So that means that, so you have to find the HCF. In the question, they have not asked you to find the HCF, but we have to find the HCF. After finding the HCF, it's given that the HCF can be expressed in this form. Now it's just solving. Now multiply 408 into 5, you get this number. Transpose. So 24 plus 2040 is this one, is equal to 1032 M. So M is equal to 2064 by 1032, which is 2. This is a very simple question. Read the question and understand. Is it fine, children?
Yes, ma'am.
Yeah. So the HCF can be expressed in this form. So that means you should find the HCF of these two numbers using any method. Any method you can find the HCF. Then see here, the HCF, this is the HCF. It can be written in this form. Once you write that, you just have to multiply this, transpose, and find the value of M. Yeah. Find the largest number which divides these two numbers, leaving remainder 6 in each case. Find the largest number. So here the word divides is very important. You should find the largest, biggest number that divides these two numbers. Divides these two numbers meaning like this one, it divides that number, divides this one. And that number divides. Divides meaning it's the denominator. That number which you're going to find, that one divides this number and this number, leaving remainder 6 in each case. So you're looking for the denominator. If you're looking for the denominator, it is the HCF. If you're looking for the numerator, it is the LCM. Because we know that the LCM is greater than the HCF. If you're looking for, okay, I don't want to explain too much now. So if you're looking for the numerator, it is the LCM. If you're looking for the denominator, it is the HCF. And that the word divides tells us. Should find the number that divides 615. So that number should divide 615 and 963, leaving a remainder 6 in each case. So that means you're looking for the HCF, the denominator. Divides means denominator. The word divides, meaning denominator, and denominator means HCF. Divisible, the word divisible suggests numerator. Numerator means LCM. So mostly you will find these words, divides and divisible. Divides, denominator. That means you should find the HCF. Divisible, meaning you should find the numerator. That means the LCM. Okay, and so here we find the word divides. That means we'll have to find the HCF. Whenever you find the HCF, subtract the remainder and then find the HCF of the two numbers. If you're finding the LCM, you should find the LCM and then you should that remainder should be used later. If you're finding the LCM, you know, you should ignore the remainder given. You should find the LCM of the given numbers and then do some changes or whatever manipulation with this remainder. Whenever you have to find the LCM, don't do any changes to the given number. Find the LCM of the given numbers and then use this information remainder 6. If you're finding the HCF, you should always change the numbers. See, this was explained already in the regular classes. So now I'm not explaining, I'm just telling you how to remember. So this is not the way it is explained, children. I'm just telling you how to remember. So if you're finding the HCF, you should do some changes to the given numbers and then find the HCF. If you're finding the HCF, if you have to find the HCF, you must change the given numbers and then find the HCF of those new numbers. If you have to find the LCM, don't change the numbers. Don't disturb the given numbers. Find the LCM and then that answer should be manipulated. So divides, denominator, HCF, change the given numbers. Change the numbers and then find HCF. And then change meaning you understand. Find HCF. Divisible meaning numerator, meaning LCM, meaning don't change the numbers. Don't change the given numbers. Manipulate later. Manipulate them later. After finding the LCM, you should change it. Okay, so from that, it's clear that you should find now, since you have to find the HCF here, 615 minus 6, 963 minus 6. Now you will get two new numbers. You must find the HCF of those two new numbers, and that is the required number. The word is divides. Divides means HCF. HCF means you should change the numbers. 615 minus 6, 963 minus 6. You get two new numbers and you have to find the HCF of those two new numbers, and that is the required number. Any method you can find the HCF. So 87 is the largest number that divides 615 and 963, leaving remainder 6 in each case. You can check it also. When you divide 615 by 87, when you divide 615 by 87, you will see that it leaves a remainder 6. And this one also, when you divide by 87, the remainder will be 6. So 87 is the largest number, the biggest number. That divides these two numbers, leaving remainder 6 in each case. Is that fine, children?
Yes.
Yeah, you can take a screenshot. I mean, we won't spend time to work all this now. You can take a screenshot. You can just go through that later if you have time. Otherwise, try to understand now. There's no time to visit everything now. So remember now. I'll just wait for a minute so that you can just rehearse that in your mind. Okay. Again, divides, you can see divides and different remainders are given. Divides, you can see divides, so HCF, and different remainders are given. So you should subtract and then find the HCF. You must subtract. -9. There the remainder was the same in both the cases. So we subtracted 6 from both. Here the remainders are different. So this one -9 and this one -5. So you get two new numbers and find the HCF of those two new numbers. And that is a required number. $154 is the greatest number that divides these two numbers, leaving remainders 9 and 5. So when you divide these two numbers by 154, you will see that in this case, the remainder is 9, and in this case, the remainder is 5. Divides HCF. Subtract and then find the HCF. Is it easy, children, to remember?
Yes.
Yeah, next one. Again, divides. 3 different remainders. 3 numbers and 3 different remainders. So you understand what to do. I'll wait for a minute, go through. EDA means Euclid's division algorithm. That is the division method, not the prime factorization method. So when there are 3 numbers, you have to first take 2 numbers. The HCF is 625. Then you should take the HCF with the third number. Should take the HCF with the third number. So you can see that 625 itself is the HCF. So it's not the regular division that you should use, multiples less than 10. You should do it directly. 625 into 25 times. It's not the regular division where you cannot write 625 10s are 11s are 12s are and all that. In the regular division, the maximum digit you place here is 9. You cannot write 12 times and all that. But here it's not like that. You can use any multiple equal to 15,625 or just less than 15,625. So you can go more than 9. So 625 25 times is this one. And that's the required number. So if you divide these 3 numbers by 625, remainder here will be 1, remainder here will be 2, and the remainder here will be 3. So again, this is HCF, children. This is in your NCRT also. Find the HCF of the 2 numbers. Now again, because the number of columns, it cannot be more than the given numbers here. The 2 numbers here are 855 and 90. The 2 numbers here are 855 and 90. Now the answer cannot be more than these 2 numbers. So sensibly, it is the HCF of the given numbers. That will be the maximum number of columns in which they can merge. All this is just HCF. Meaning it will be simple for you. You know this one also. Why it's a composite number, you know. So in such questions, you will not find the word divisible or divides. So here, how do you, understand if it is the HCF or LCM? So 36 and 45 are the two numbers. If you're looking for a number more than these two numbers, then it's the LCM. Because you can gauge the answer. You can gauge the answer. You can make out if the answer, meaning the value of the answer you can gauge if it should be more than 36 and 45 or less than the two numbers. So these boys, to do one round, they take 36 minutes and 45 minutes. So when will they meet again? Obviously, they'll not meet in less than 45 minutes. To complete one round itself, the second boy takes 45 minutes. So obviously, for the two boys to meet again at the starting point, the answer should be more than 45. So if it is more than 45, it is the LCM. Now, if supposing by mistake you find the HCF, you will get 9. Can they meet in 9 minutes? They need 36 and 45 minutes to make one round. How can they meet in 9 minutes? So the answer does not make sense. So even if you go wrong, you can, see if the answer makes sense, and it will not. So it is the LCM. So sometimes when we have to find, the LCM of numbers like this, see here. See, here we have to find the LCM of 7.5, 6 and 5. So you can multiply because 7.5, so you can multiply every number by 2. You can multiply every number by 2. So I got 15, 12 and 10 and find the LCM of these numbers. So since you multiplied by 2, divide the LCM by 2. That will be the LCM of these numbers. Supposing you have to find the LCM of 7.5, 6.5 and like something like that. And some 3. Multiply the numbers so that you get a whole number. You can multiply by any number so that you get a whole number in all the case. You cannot multiply the numbers by different numbers. You cannot multiply this by 2, this by 3 and this by 4. Not like that. All the numbers by one same number, and that number can be any number. So here when you multiply by 2, you can even multiply by 4. You can even multiply by 4, then divide the LCM by 4. But it's enough to multiply by 2, no? Because 7.5 into 2 is 15. So find the LCM of 15, 12 and 10, 60. Now divide that LCM by 2. This is the LCM of the numbers 7.5, 6 and 5. Yeah, help yourself and take a screenshot. Go through. All right, children. Find the smallest number. See if divisible. So divisible means, see, find the smallest number which when increased by 17 is exactly divisible by these two numbers. That number is divisible by these two. That number which you're going to find, will be divisible by 520 and that number will be divisible by 468. So you're looking for the numerator, LCM. And to find LCM, find the LCM of the given numbers and then manipulate that answer. Should find the LCM of the two numbers, the two given numbers. The required number is the LCM of the two given numbers minus 17. So find the LCM. When you find the LCM, what happens? 4680 by 520, exactly divisible. 4680 by 468, exactly divisible. No, find the smallest number which when increased by 17 is exactly divisible. So the 4680 is exactly divisible by these two numbers. No, you should find the number, that number when increased by 17. So subtract 17 then. 4680 minus 17. This is the required number. 4663 is the required number. Because if you increase this number by 17, then you will get 4680. And that 4680 is exactly divisible by 520 and 468. When you find the LCM 4680, you know that the LCM will be exactly divisible by the two numbers. When you find the LCM, you know that the LCM is exactly divisible by the two given numbers. But no, you should find the number. That number when increased by 17, it should be divisible. So that means reduce the LCM by 17. So this is the required number because when you increase this one by 17, then you will get this one. And this is exactly divisible. So when the situation is to find the LCM, find the LCM and then you should adjust the answer. You may have to add or subtract. That depends on the situation. Go to the answer, children. I'll just come back. Yeah, children, I'm back. So as usual here, divided. Okay, so it's not divisible, so don't get confused. Now find the smallest number which leaves remainders. This and this when divided by that number, when divided by 28, that number when divided by 32. That number when divided by 28, that number when divided by 32. So since you have to find the numerator, it is the LCM. So when you're finding the LCM, don't change the given numbers. Find the LCM of the given numbers 28 and 32. And you get the LCM as 224. 224. Now the remainders are different. Now let's take it up one by one. So 224 is exactly divisible by 28. No, but they want a remainder 8. Then what should be the number? If the remainder should be 8, that means this number 224, what is its earlier meaning? Subtract 28, 224 minus, no, let me not put it that way. Now, if the remainder, okay, 224 divided by 28. Now, this is exactly divisible. If the remainder should be 8, that means this number should be 20 less because it's 28, right? It's 28. So if you should get 8 as a remainder, then this number should be 20 less. So 224 minus 20. Okay, so what do you get? 204. So now divide 204 by 28. Divide 204 by 28. What have we done? How did we get 204? Because when you divide by 28, no, the remainder should be 8. 28 and the remainder should be 8. So the number should be 20 less. LCM should be 20 less. So now you divide 28. How many times, children? Not exactly divisible, but 28, I think 7 times. 196. I use the calculator. 7 times 196. And you can see the remainder is 8. In the same way for the next one, 224. When you divide 224 by 32, it's exactly divisible. No, but they want the remainder to be 12. If the remainder should be 12, then again it should be 20 less because 32. If the remainder should be 12, that means the number should be 20 less, 224, 20 less than that. You can divide and see. So 204 divided by 32. So 32 6 times. Yeah, 192. 6 times 192. And the remainder is 2 and 1. Yeah, 12. So which means 28 minus 8, 20. And 32 minus 12, 20. You should subtract the 20 from the LCM. See, 224 is the LCM. Now 28, see, you should get the earlier number. Now when divisible by 28, so 28 meaning 20 and the remainder 8. So if you want remainder, if the remainder should be 8, that means this number should, if you reduce it by 20, if you reduce this by 20, so for 28 there is 20, but 8, you need 8 more. So that will be the remainder. Okay. So you try your way to remember this. I tried my best to say it. Again, numerator, LCM. LCM, you should always find the LCM and then change the number. So we found the LCM 224, different remainders. So you can remember like this, minus 8 and minus 12. So you get 20. You get 20. That 20 you should subtract from the LCM. You can remember like this. 204. See, these are 3 different situations. This is when increased by, see, all are 3 different situations. So here also you'll have to find the numerator, because that number when divided by 35, that number, when you divide that number by 35, that smallest number, whatever you're finding, you know, that number when you divide by 35, that number when you divide by 56, that number when you divide by 91. Clearly, you have to find the numerator, which is the LCM. LCM means first find the LCM of 35, 56, and 91. Now, LCM is exactly divisible by 35, 56, and 91. No, it should not be exactly divisible. It should leave remainder 7. Then increase the LCM by 7, that's all. If you increase the LCM by 7, then when you divide the LCM by these three numbers, the remainder will be 7. Because if it is LCM, remainder will be 0. If you increase the LCM by 1, 1 will be the remainder. If you increase the LCM by 2, 2 will be the remainder. Increase it by 7, 7 will be the remainder. All right. Greatest 6-digit number, exactly divisible by these three numbers. So LCM, and you should find that multiple of the LCM, which is the greatest. See, the number need not be the greatest 6-digit number. That number which you find should be the greatest 6-digit number that's exactly divisible by these three numbers. So find the LCM, and then you should find that multiple of the LCM, which is the greatest 6-digit number divisible by these three. So the LCM of the three numbers is 360. So then what I did, I took up the greatest 6-digit number. Perform the division. So you can see the quotient is 277. So then I multiplied 360 with 277. So 99,720 is the greatest. Oh, that's a 5-digit number, no? Oh, I should take the next number. No, I've gone wrong in multiple. Sorry, children, there's something. This is not the answer. The method is correct. Let's correct it now. I think I worked it for the greatest 5-digit number. Yeah. I'll tell you if the greatest 6-digit number, I'll tell you what you should take. But I think I've worked this for the greatest 5-digit number. I might have made a mistake in typing this. Okay, children. It's the same, no? The method is going to be the same. So it doesn't matter if it is 5-digit or 6-digit. Yeah. Not confuse you with this slide. Let me do one thing. Let me work for the 6-digit number itself. Leave that. Forget that. Let's do for this one, children. So the LCM we can take from here. It is 360. The LCM is 360. LCM of 24, 15, and 36 is 360. Now we need to find the greatest 6-digit number. So the greatest 6-digit number is 99999 1, 2, 3, 4, 5, 6. This is the greatest 6-digit number. We need to find the greatest 6-digit number that's exactly divisible by these three numbers. So all of you perform the division. Divide and tell me the quotient. Divide this by 360 and tell me the quotient. Yes, children, what's the quotient?
It's 2777.7.
Division then. I've written 277, I think. That's what. Okay, so leave that. So 277 you said. Okay, so now multiply 360 with, forget the remainder. We don't want that remainder and all that. We just want this quotient. 2777. What's the product? I'm using the calculator. 360 into 9,99,720. You can try 360 into 2778, the next number. So 360 into 2778 is a 7-digit number. 10,80,000. So first find the LCM of the given three numbers. Find the LCM of the given three numbers. And since you are looking for the greatest 6-digit number, take up the greatest 6-digit number and perform the regular long division. So the quotient will give you some idea. Multiply 360 with the quotient 2,777. And if you're not sure about this answer, if you're like, what if it is 360 into 2778? Check that. That will be a 7-digit number. But we want the greatest 6-digit number. So this is not the greatest 6-digit number. This is the greatest 6-digit number exactly divisible by 24, 15, and 36. What is LCM? LCM is the smallest number. LCM is the smallest number that is divisible by 24, 15, and 36. 360 is the smallest number that is exactly divisible by 24, 15, and 36. There is no number smaller than 360. There is no number smaller than 360 that is divisible by all these three numbers. That is what is LCM, least common multiple. The smallest common multiple of these three numbers. So they don't want this answer. The question is, they want the greatest 6-digit number that's exactly divisible by these three numbers. So it should be a multiple of the LCM. It should be a multiple of the LCM. That number is a multiple of the LCM. So it can be 360 into 11, 360 into 12, 360 into 13, 360 into 14. We don't know. So to get an idea, we do this long division. So it is 360 into 2777. How can we guess that? So do this division so you get the quotient, find that product, and you can check with the successor 2778. All eligible. To change the slide. So similar, greater than, find the number nearest to this, but greater than this, which is exactly divisible by. So that number should be exactly divisible by these three numbers. So LCM. And you should find the LCM and you should find a multiple of the LCM in this range. You must find a multiple of the LCM in this range. That number should be greater than 1 lakh. But and nearest to, that means less than 1,10,000. Nearest to that means it should be less than that. Just less than 1,10,000. The required number should be more than 1 lakh, but it should be just less than 1,10,000. So you should find that multiple of the LCM. You should find the LCM and you should find that multiple of the LCM. I hope my division is right here, children. Just have a look. Somebody's at the door. I'll come back. Yeah, children. So if you try 840 into 131, it'll be more than 1,10,000. So if you do 840 to 131, you get 1,10,040. 1,10,040, which is more than 1,10,000. So in all these questions, you'll have to find a multiple of the LCM. Find the LCM and find a multiple of the LCM that satisfies the condition given. Find the least number that's divisible by all numbers from 1 to 10. All numbers from 1 to 10. So just find the factors of all the numbers. 1 is just 1. 1 is 1, 2, 2, 3, 3. 4 is 2 squared. 6 is 2 into 3. 2 cubed, 3 squared, 2 into 5. So you should find the LCM of all these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So write all the prime factors and raise them, write all the prime factors and raise it to the greatest power. All the prime factors once. So you have 2, 3, 5, 7 with the greatest power. So this is the number. This is smallest number that's divisible by all the numbers from 1 to 10. You can take a picture of all this and go through this later, children. You can understand all this. So this one they'll change at a later time. They change only after 48, 72 and 108 seconds. So you cannot answer any answer less than 108 will not serve the purpose because at the third one, the lights change only after 108 seconds. So you're looking for an answer more than 108. So LCM. LCM is 432 seconds. So okay. Okay. I'm not writing, it's a case study based question, children. I'm not writing that passage. So this is a banner, okay? This is a banner, triangular in shape. This is a banner, it has some information. Okay, it's triangular in shape. Now this is the first question. Yeah, answer this question, children. If the cost per meter square of the banner is ₹2, find the cost of the banner. We'll answer this and then take up the next question. Yeah. Tell me the answer for this. Okay, they are making 10 banners like this, children. Find the cost of the campaign. Sorry. On the banner, it is no smoking. The banner says no smoking, and the banner has, the information regarding the, the effects of smoking on human health. So 10 such banners are made. 10 such banners. You have to find the cost of the campaign.
200 rupees, ma'am.
200, is it?
Yes, ma'am.
Yeah. So very good. So the how do you find the area of the triangle? Half base into height. What's the base from here to here? So this is 6. So like here it is 6, and this one is 1 from the coordinates. From the coordinates, see, this is 6,1. So here it is 6. This is 1,1. So here it's 1. So what is this? How much is this one? 5 units. So AB is 5 units, and AC, what's the marking here? 1,1. So y coordinate is 1 here, and this is 1,5. So y coordinate here is 5. So 4 units. 5 minus 1, 4. So AB is equal to 5 units, and AC is equal to 4 units. Area of the triangle is half into base into height, 5 into 4. So 10, 10. And since the cost of one banner, so the area of the triangle is 10 meters square, because it's given here cost per meter square. So 10 meters square. So cost of one banner is 10 into 2, rupees 20. So 10 such banners will be into 10, 200. Find the area of the triangle. That is the area of one banner, one triangular banner, into 2 rupees, cost of one banner, into 10, cost of 10 banners, or the cost of the campaign. Meaning how much they have to spend to conduct this campaign. Okay, next question. The English is quite bad in the questions. I'm just writing as I see here. Okay, I'm not correcting it now. If we want to draw a circumscribed circle, find the coordinates of the center of the circle. How will you do this, children? How will you find the coordinates of the center of the circle? Center of the, okay, how will you find the coordinates of the circumcenter? Correct? Because circumcircle, so circumcenter. Please answer my question. Do not work. If we
Ma'am, by
want,
using centroid formula.
no, only in an equilateral triangle, the centroid, the circumcenter, the incenter will coincide. Not in all the triangles. Is this a right triangle? It is a right triangle. So there is a very important property to be used here, children. Only in an since Shreyas raised it, I'll just complete that. In an equilateral triangle, the circumcenter, incenter, the centroid, orthocenter all coincide. Circumcenter is the center of the circumcircle. Incenter is the center of the incircle. Centroid is the point of concurrence of the medians of the triangle. Orthocenter is the point of concurrence of the altitudes of a triangle. Now, only in the case of an equilateral triangle, the circumcenter, incenter, centroid, orthocenter coincide. In other triangles, it's different. You can't say they're different. But there is a very important property of the circumcenter to a right triangle. The circumcenter of a right triangle lies on the midpoint of the hypotenuse. Very important. Circumcenter in a right triangle lies on the midpoint, of the hypotenuse. Circumcenter in a right triangle lies on the midpoint of the hypotenuse. You can easily remember that because see, This is the circumcenter. The circumcircle is, I'm sorry, okay. So this is the circumcenter because the midpoint, because this is 90 degrees, right? We know that angle in a semicircle is a right angle. So that means this one is the hypotenuse is the diameter. See, this is the circumcircle. Excuse me, okay, it's not passing through this. It's a circumcircle. Okay, and since this is 90 degrees, the hypotenuse of the right triangle is the diameter of the circumcircle. Because it's 90 here, angle in a semicircle is the right angle. So that means the hypotenuse is the diameter. That means the midpoint of the hypotenuse is the center of the circle. And that's why it's the circumcenter. Am I clear, children?
Yes, ma'am.
Okay. Yeah. Please do that. You should not do that lengthy procedure. That is calling the circumcenter as x comma y, and finding supposing the circumcenter O is x comma y. You have to find OA, OB, OC. You'll get 3 equations and then equating OA and OB, OC. No, you should not do that lengthy procedure because at the right triangle, simply the midpoint of BC. So midpoint of BC. What is the midpoint of BC? 1 plus 6 by 2, comma 5 plus 1 by 2. 7 by 2, 3.5, comma 3. Coordinates of the circumcenter. Understood, children?
Yes, ma'am.
Okay, thank you, Ram. Okay, the next question is, if we draw the image of a figure about the line BC, then find the total area. Okay, if we draw the image of the figure about BC, so it's kind of, the figure is reflected along BC. If BC is the mirror, and this image is reflected, then what is the total area is the question. I'm not writing it. See, this is the question. If we draw the image of the figure about the line BC, that means BC acts as the mirror and the reflection is formed on the other side. Find the total area. So what will be the total area, children? What is the area of the triangle we found earlier? Children, quick. What's the area of the triangle we found earlier? Half into 5 into 4. 10. Nobody's answering. Very bad.
Yes, ma'am.
10. So now image, so 10 plus 10, 20 will be the total area. Because if the triangle is reflected along BC, same area it will have. So 10 here, image 10, so totally 20. The next question is, find the centroid of the given triangle. That's the next question. The total area we answered already. Orally we did it. 10 plus 10, 20. Now next question. Find the centroid of the given triangle. Yes, children, now work that. Find the centroid of the given triangle.
4, 7 by 2.
1 plus 6. 8 by 3. Hey, you divided. See,
Sorry.
Ram, you divided by 2. X1 plus X2 plus X3 by 3. Y1 plus Y2 plus Y3 by 3. Yes.
Yes.
It's okay. Meaning it's natural to make that mistake because we've been doing by 2, but we need to be careful.
Yes, ma'am.
So what is it, Ram?
8 by 3 and 7 by 3, ma'am.
Very good. 8 by 3 and 7 by 3. That's all. So we've answered one case study based question. We'll see the next one. I'm clearing the screen. Okay. Okay, children. Next question. Okay. I'm reading the information given. Listen carefully. A bookseller has 420 science stream books. 420 science books. Okay. And 130 arts books. Arts books. He wants to stack them in a way that each stack has the same number and they take up the least area of the surface. Each stack should have the same number. He wants to arrange them in such a way that every stack has the same number of books. Now here are the questions. Listen to this. I'm not writing this. If a number, the question is different. Listen, if a number has no factors other than 1 and the number itself, what is it called?
Prime number.
Prime number. It's a prime number. If a number has no factors other than 1 and the number itself, it's a prime number. Now this question you have to work. What is the maximum number of books that can be placed in each stack for this purpose? You should find the maximum number of books that can be placed in each stack. So will the number of books in each stack be more than 420? Will the number of books in each stack be more than the given numbers? No. So
No,
it'll definitely be less than the books. It will be less than 130 in fact. That means you should find the HCF. Find the HCF quickly.
Ma'am, is the HCF 10?
10 now.
HCF is 10. 420, 130, 3 times 390, 30. Yeah, 10. 130, 4 times 120, 10. Yeah, it's 10. HCF is 10. So the maximum number of books that can be placed in each stack is 10. So how many stacks of science books? How many stacks of science books?
42.
42 stacks. 42 stacks of science books. And how many stacks of arts books?
13.
13.
13. 13 stacks. So totally how many stacks? 42 plus 13. So totally there'll be 55 stacks. 55 stacks. Okay, next question is, if the bookseller doubles the quantity, then what is the maximum number of books that can be placed in each stack? If the bookseller doubles the number of books, that means he has 840 and 260. 840 and 260. Then what is the number of books that can be placed in each stack?
20.
20. So that also is doubled. The number of books in each stack is also doubled. If he doubles the number of books, then the number of books that can be placed in each stack is also doubled. Because see, okay, fine. We don't have time, so yeah, that's right. Just double the number of books. You don't have to find the HCF again, but even if you find, you will get 20. So the number of books in each stack is also doubled. Okay, then the last question is find the LCM of the two numbers. So that you can find. Find the LCM of the two numbers you can find. Okay, next one. Okay, so a person has taken loan from a bank. Okay, loan, and the value of the loan is rupees 1,18,000. No. Yeah, 1,18,000. Yeah, 1,18,000. Okay. So how does he repay? First installment, he repays like this. First installment, 1,000 rupees, and increases. The first monthly installment, this is. Okay. So first monthly installment. Okay, rupees 1,000, and increases every month. That is, he increases the installment paid every month by rupees 100. First month he pays 1,000. Then he increases the amount of the installment by 100 every month. Every month he increases by 100. Now, based on this, so the total loan is 1,18,000. First month, now he has to repay, right? You take a loan, you have to repay. So first monthly installment, 1,000 rupees. Every month it increases by 100. Now, these are the questions. Answer the first question. children, maybe you have to have your breakfast. We'll just come back. I'll give you some 10-15 minutes time. So you can eat or yeah, you can just refresh and come back. Okay. I can do the class till 11. So those who are interested in staying back can stay back. Till about 11:30, I can do the class. So if you're interested in staying, we'll do only case study based questions. So if you're interested, you can stay back. If there's at least one person in the meeting, yes, I can go on. If all of you leave, yeah, then I have to end the meeting. So that's the information for now. So I'll come back in 10 minutes. In the meantime, even you can finish your breakfast. Yeah, children, I'm here. Let me know if you all finished working this one. I'll give you the next question.
Yes, ma'am.
Yeah. Once you finish working all the 4 subdivisions, let me know. We'll see the answer and go to the next one. Yes, what's the amount paid by him in the 30th installment? You have to find A30 or S30.
A30.
A30.
A30. And what is the A30? What's the amount paid in the 30th installment?
3,900.
Correct, 3,900. Okay, next one. The amount paid by him in the 30 installments. Is that A30 or S30?
S30.
S30. Yeah, because in the 30 installments, find the amount paid by him in the 30 installments. So 30, all the 30 installments. The first one is the 30th installment. That particular installment. So second one is S30. And how much is that?
73,500.
Correct, 73,500. You need to find S30, which is 73500. Okay, what amount does he still have to pay after the 30th installment?
44,500.
Correct, 44,500, because the total money he owes is this one. Of that, in 30 installments, he's already paid, what did you say? 73,500. So the total money due is 1,18,000, and in 30 installments, he's cleared the debt to the extent 73,500. So the difference 44,500 is still due to be paid. 44,500. And the last one, what is the amount to be paid in the last installment? That is the 40th installment. 4,900, right?
Yes, ma'am.
Yeah, 4,900. A40. The 40th installment, that particular term, the 40th term, 4,900. Okay, next one. Now, say a person borrows 50,000 at 8% simple interest. Okay, a person borrows 50,000 at 8% simple interest. And the time duration is 5 years. No, not 5 years. 25 years. 25 years. Now, in the case of simple interest, see, like in the earlier example, this person will clear the loan. This person will clear the loan in 40 installments. All of you find, for this question, all of you find S40, children. Sorry, it's not asked, but please find S40 for this. S40 is equal to
1,18,000.
1 lakh.
18. Oh,
Exactly.
1,18,000. Ah, yes, ma'am.
So that means on this loan, there is no interest charge. All of you are getting the same thing?
Yes, ma'am.
Okay, fine. So in this case, since the sum of all the installments is equal to the loan value, that means there is no interest charge. There is no interest charged. Exactly this amount. So this is a soft loan. It's called a soft loan. A soft loan is a loan where no interest is charged. You just have to return the principal value. The principal value of the loan is 1,18,000. And in some installments and 40 installments, you repay only that 1,18,000. So monthly 40 installments means 36 months plus 4 months, 40. So 3 years, 40 installments, 40 monthly installments means 3 years and 4 months. So that person who was given the loan is not charging any interest for 3 years and 4 months. Okay. Now this case, so supposing it was 2 lakhs, okay, S40, supposing it was 2 lakhs, then the difference is the interest charged. The difference, actually the loan amount is 1,18,000. But S40 is 2 lakhs. The difference is the interest charged. The difference 2 lakhs minus 1,18,000 is the interest charged by the money lender. Now see this case. This is a bank. A person borrows 50,000. 8% simple interest for 25 years. So this means when you borrow 50,000 from a bank for 25 years, or some person who's lending money for 25 years under simple interest, that means every year you'll pay the simple interest, and at the end of 25 years you'll have to return the 50,000. That's how simple interest works. That is how simple interest works. Simple interest means every year you'll pay the interest alone. For 25 years, you will pay the interest alone to the bank. Interest you will pay for 25 years. At the end of 25 years, you will pay the interest for that year and you will return the principal value of 50,000. That's how simple interest works. So if you borrow 50,000 from a bank or from any person who lends it to you at 8% simple interest for 25 years. That means every year for 25 years, you will pay the interest alone. The interest portion at 8% you'll pay for 25 years. At the end of 25 years, you'll pay the interest for that year and you'll return the principal money of 50,000. Okay, so I've told you how simple interest works. Now answer the question. So the principal is 50,000. Money borrowed is 50,000. 8% simple interest for 25 years. Children, don't ask any further questions based on further questions related to this question. Just work and we'll discuss the answer later. Find the interest. Yeah, what is the interest paid in the 25th year, children? Okay. So it's The question may look like it is an AP or something, but it's not. See here, every year the interest paid will be the same. Every year, the interest paid will be the same. Every year you will pay, the simple interest paid annually will be 50,000 into 8%. Into 8% every year. So 1 year by 100. PTR by 100 or PNR by 100, whatever you call it. Okay, so so 4,000 is the interest you will be paying every year. So even in the 25th year, you will pay 4,000 only. See, that's how simple interest works. Simple interest means the interest is same every year. Now, supposing you have deposited 50,000 in the bank, which gives you 8% simple interest, and you keep the money in the bank for 25 years. At the end of every year, the bank will credit 4,000 in your account. That's the interest for every year. End of first year, the bank would have credited 4,000 interest in your account. End of second year, same amount, 4,000 in your account. Interest 4,000. Every year, the interest, whether you have to pay or receive. If you borrow, you pay. If you have invested in the bank, you receive that interest. The value of the interest is the same every year because it is simple interest. In simple interest, the principal value does not change every year. The principal value is fixed for 25 years. It is 50,000 for all the 25 years. While in compound interest, the principal value changes every year. So simple interest, 4,000. See, now don't ask me why you've not taken 25 as the time. The interest value is the same for every year. So time is 1 year. 50,000 into 8 into 1 by 100 is 4,000. 4,000 is the interest which you have to pay or receive every year at the end of every year. So the interest paid in the 25th year is 4,000. The interest that you pay, because it is simple interest, the interest that you pay in the 25th year is 4,000. And the total money paid to the bank at the end of 25 years. What is that? You would have paid, amount paid will be every year you paid 4,000 rupees for 25 years. So this is the interest you have paid plus the principal of 50,000 you will return. The amount which you will settle at the end of 25 years will be every year you've been paying 4,000 rupees interest to the bank. Every year amount settled or amount paid at the end of 25 years will be every year you've been going to the bank and paying 4,000 interest. Like this you've been doing for 25 years. And at the end of the 25th year, you will have to refund, not refund, sorry, return the principal money of 5,000. So this is the amount paid at the end of the 25th year. The total money which you have spent. Now I'll give you another situation like this, which can be worked using the concept of arithmetic progressions. Is this clear, children?
Yes, ma'am.
When it is simple interest, the interest which you pay every year is the same. The principal does not change every year. For the entire time period, the principal is 50,000. For the entire time period, the interest is 4,000. That you will get from the bank if you have deposited. You will have to pay if you have taken a loan. Every year, 4,000, 4,000, 4,000, 4,000 for 25 years. So 4,000 to 25, you have paid as interest. But you cannot come away like that. You'll have to return the principal value of 50,000. Because all these 25 years, you've been paying only the interest. Now you should return the principal value of 50,000. So that's the total amount paid. Okay. Think different. Think now. Don't use the meaning. Don't be fixed with the earlier idea. You read the question and like work it accordingly. This we'll have to think differently. So a sum of rupees 8,000 is invested at 10% simple interest per year. It's not invested for 1 year. The bank gives you 10% simple interest for 1 year. Calculate the end interest. So see here, calculate the interest at the end of each year. Calculate the interest at the end of each year, meaning, but this is how the simple interest formula works. If you have to find the simple interest at the end of the first year, if you have to find the simple interest at the end of the first year, then you should use the time as 1. Simple interest at the end of first year. Simple interest at the end of second year. Simple interest at the end of third year. So this simple interest means principal which is 8,000 into rate into time. Go back to 7th standard into time. End of first year by 100. Simple interest into rate into time. But understand the meaning in this context. You will not pay this money at the end of the second year. Every year you will pay only 800 rupees as interest. But the simple interest at the end of the second year is calculated like this. 8,000 into 10 into 3 by 100 into 4 by 100. Just work this, children. I'm just coming back. So now you'll have to answer. Do these interests form an AP? If so, find the interest at the end of 20 years. Give me 2 minutes, children. I'll just come back. Yes, children. So do the interest form an AP? Do the interest form an AP?
Yes, ma'am.
What is the interest at the end of the first year?
800.
At the end of the second year?
1,600.
1,600.
So if do these interests form an AP? Yes, they form an AP. Find the interest at the end of 20 years.
16,000.
Is it A20 or S20? Is it A20 or S20?
A20, ma'am.
Oh, you found using the formula, is it? Okay. So simple interest at the end of 20 years, you did the same thing, is it, children?
Yes, ma'am.
Oh, okay. Oh, yeah, that's why I understood you from your reaction. No, after this, because it's given to these interest form an AP. If so, find the interest at the end of 20 years using this fact. Using this fact, meaning using the fact that it's an AP. Using this fact, meaning the fact that it's an AP, using that form, using the fact that the numbers form an AP, find the interest at the end of 20 years. So you have to find using A20 or S20. Is it A20 or S20? Okay, now we won't spend more time on this. It is A20. It's not S20, it's A20. Okay. Just share the picture. All of you just get your NCRT textbook, open to page 115, question number 5. 115, question number 5. I'll just unshare my screen, children. Yeah, I've shared my screen again. Yes, children, we need to now. This one is made of concrete. Okay. The staircase is made of concrete. You need to find the volume of concrete used to make the staircase. You need to find the volume of concrete used to make this staircase. Okay. So volume of concrete used is equal to volume of the first cuboid. Every stair is cuboid, is a cuboid. See, every stair is a cuboid. See here, if you draw a line like this one is a cuboid. Everything is like a wall, no? Like a small wall and then a little bigger, a little bigger. Each of this is a cuboid. Each of this is a cuboid. Yes or no, children? All these are cuboids. Every stair, you know, is a cuboid. Because it's not open here. It's concrete. It's fully covered. Don't think you can go under the staircase and come out from that end. No. It's completely, concrete is used everywhere. It's not hollow here. So every stair is a cuboid. So volume of concrete is equal to volume of the first cuboid plus volume of the second cuboid plus volume of the third cuboid. How many cuboids are used? How many stairs are there? 15 steps, right?
Yes, ma'am.
There are 15 steps. So till plus V15. So every step is a cuboid. Every step is a cuboid. The total volume of concrete used is volume of the first step, the volume of the concrete in the first step, plus the volume of the concrete in the second step, plus the volume of the concrete in the third step, plus volume of so on till volume of the concrete in the 15th step. Okay, so that is equal to, it's a cuboid, so LBH. The length is the same everywhere, 50 meters. So L. B, breadth, is the breadth the same? Yes, the breadth is the same. Everywhere the breadth is half a meter. Breadth is the tread. Half a meter. Everywhere. The length you can see, it's marked here, 50 meters. Length, 50 meters. You can see here, the length of every cuboid is 50, will be 50. The breadth is this one I'm saying, the step, you know, where you sit. That is the same everywhere. Where you sit, you know, that width is the same everywhere. The height is different. The height obviously is different. So for the first step, the height is 1/4 meter. Then for the second step, it is half a meter. The third step, the height is 3/4 meters. 1 meter, 1/4 meters. So it increases. Sorry, it increases by quarter meter. The height of each step increases by quarter meter when compared to the earlier step. The length is 50 meters. The length is 50 for every cuboid. The breadth is half a meter for every cuboid. Breadth is where you sit. That is the same for every step. That breadth is the same. Height is the only thing that varies with every step. It keeps increasing. So volume of a cuboid we know as LBH. So L and B is the same for everything. H1 plus LBH2 plus LBH3 plus LBH15. Am I right, children? Length and breadth is the same everywhere. So height is the only thing that changes with every step. So H1, H2, H3, and it's LBH because every step is a cuboid. Now LB is common. LB is common. H1 plus H2 plus H3 plus H15. So length is 50 meters, breadth is half a meter into H1. It starts with the height of the first step is quarter meter. Second step is quarter plus quarter half. Half plus quarter 3/4. Like this 15 terms. Like this 15 terms. Where A is 1/4, D is 1/4, and N is 15. So this on cancelling, you will get 25 into. Here you should find A15 or S15, children.
Yes, 15.
S15 into S15 into, I've cancelled this, okay? This is 25. So this half is gone. So now we'll have to only work the bracket. We'll have to only work the bracket. You should find S15. So find that, and that's the volume of the concrete. That answer will be in meter cubed. Please finish it. So like this certain situation, you need to convert, meaning you should try to use AP. It will not be given. Yeah, what's the total volume of the concrete?
750 meter cube, ma'am.
Okay, fine. 750. What is S15? 30, yeah?
30, ma'am.
Okay. All right. What is the solid traced when a right triangle is made to revolve about its hypotenuse? If a right triangle ABC is made to turn about its hypotenuse BC, then the solid generated is a
Double cone.
double cone. Is a double cone. So if this is 10 and this is 24. Find the volume and the surface area of the double cone. Find the volume and surface area. You can use pi as 3.14. You can use pi as 3.14. Find volume and surface area of the double cone. So you can find the hypotenuse. BC is 26. You can mark this point O. BC is equal to 26 using Pythagoras theorem. Now, the simplest way is find the area of the triangle. Find area of triangle. What is area of triangle ABC? Area of the triangle ABC is half base into height. Half into base AB into height AC. So it is half into 10 into 24, which is 120 centimeters square. Now, half into base BC into height AO will also be 120. Half into base BC into height AO will also be 120. So half into BC is 26 into AO is equal to 120. So AO is equal to, this is 13 on cancelling, 120 by 13 centimeter. This is enough. AO is sufficient to answer the questions. Now, we need to find the volume. Volume of the double cone is equal to 1 by 3 pi r square. R square is AO square, AO the whole square, because that's a radius, right? Into H, which is BO for the small cone. For the big cone, see, I don't have place here, so I'm writing it below, plus 1 by 3 pi r square. Same thing, AO the whole square. Into 1 by 3 pi r square into H. H is OC. So the sum of these two volumes is the volume of the double cone. The sum of these two volumes is the volume of the double cone. So what's common? 1 by 3 pi into AO square is common. So in the bracket, you will get BO plus OC. BO plus OC. So 1 by 3 into 3.14 into AO square, which is 120 by 13. 120 by 13 into 120 by 13. Into BO plus OC, which is 26. BO plus OC, which is BC, 26. So you should calculate this. This will be the volume of the double cone. It is enough if you find AO like this. Find the area of triangle ABC and use that area to find AO, the altitude AO, which is the radius of the two cones. That is sufficient to answer the question. Volume and surface area. So this is volume. Surface area, it's only the curved surface area that is exposed. TSA is not exposed, meaning the circles are not exposed. You cannot see the circles. So it is pi RL plus pi RL. Pi RL plus pi RL. Pi, radius is the same. So R, L, slant height, they are different. So like L1 plus L2. Pi R, L1 plus L2. CSA. Since R is the same for both, slant height, they're different. So pi is, 3.14 and R, is, what's the radius? 120 by 13 into L1 plus L2. L1, what is L1, children? Slant
10.
height of the small cone?
10.
10. And the slant height of the big cone?
24.
24. That's it. This will be the CSA, the surface area. Okay. Yeah, just prepare the frequency table alone, children. I know you know to find the mode. Just prepare the frequency distribution. So 0, 20, 40, 60, 80, 100, 120 are the upper limits or lower limits? Am I audible?
Yes, ma'am.
Yeah, no. 0, 20, 40, 60, 80, 100, 120. They are the upper or lower limits?
Lower limits.
Lower limits. They are the lower limits. So write them 0, 20, 40, 60, 80, 100. And I've told you, if there is anything with 0 frequency, just remove it. Just take it away. If there's anything with frequency or cumulative frequency 0, just take it away. Okay, now the frequency. So when it is a more than cumulative frequency distribution, start subtracting. Start subtracting 50 minus 43, 43 minus 35, 35 minus 23, 23 minus 13, 13 minus 5. Subtract and write the last frequency as it is. Subtract. So you get 7 here, you get 8 here, 12, 10, and 8. Write the last frequency as it is, 5. So when it is the more than cumulative frequency distribution, first thing is if there's a cumulative frequency 0, just take away that information. Strike out that information. Now for the other greater than values, those numbers are the lower limits. So to the upper limit, you can fill 0 to 20, 20 to 40, to 60, to 80, 100, 120. Now the frequency starts subtracting. Start subtracting. So 7, 8, 12, 10, 8. These are the frequencies. For the last, write the last frequency as it is. Yes or no, children?
Yes, ma'am.
Yeah. If you're given a less than table, what are these values? The upper limits. Less than 10, less than 20. See, these are the upper limits. So 10, 20, 30, 40, 50, 60. They are the upper limits. So fill the corresponding lower limits. Now we don't strike out anything because all of them, there's no value 0 here. Now for when you're given the less than cumulative frequency distribution, write the first frequency as it is and then start subtracting. 22 minus, write the first one as it is, 14. Now start subtracting 22 minus 14, 37 minus 22, 58 minus 37, 67 minus 58, and 75 minus 67. These are the frequencies. For less than, write the first frequency as it is. Basically, you need to write the smallest value as it is. That's all it is. Whichever is the smallest value, write that as it is. So here in the less than cumulative frequency distribution, the first value will be the smallest. 14, 22, 37 will keep increasing. So write that smallest value 14 as it is. Then start subtracting. To get the other frequencies. In the more than distribution, Which is the lowest, which is the smallest value here?
0.
This Z. No, that you should remove. That you've already taken away that. So which is the smallest value here? 5.
5.
So that means you should start subtracting and write that last value as it is. The smallest value you should write as it is. So you should start subtracting then. Okay. Now you all know how to prove that, root 2, root 3, root 5 and all that are irrational. Now prove that 3 minus root 5. Prove that 3 minus root 5 is irrational. How do we do this? You don't have to prove that root 5 is irrational. Prove that 3 minus root 5 is irrational. Yeah, start. Prove that 3 minus root 5 is irrational. We'll do it together. Don't write in your notebook. Tell me, I'll write.
3 minus root 5 is equal to a by b, ma'am.
Okay.
And then we can consider a and b as co-primes.
Okay.
And then minus root 5 is equal to a by b minus 3. Ma'am.
Okay.
A minus 3b by b, ma'am. Next, minus root 5 is equal to.
Then we'll change the signs on both the sides.
Hmm.
No, we'll just. No, there's a minus here, no?
Yes, ma'am.
Yeah. So we'll multiply both the sides by the minus sign.
Yes, ma'am.
We need to get rid of this minus sign. Or what you can do is you transpose this one. Instead of doing all that, you transpose root 5. So that it's already positive.
Yes, ma'am.
3 minus a by b is equal to root 5. So it's already positive. 3b minus a by b is equal to root 5. Yeah, after this, Ram?
Yeah.
So after this, what you have to say is a, b and 3 are integers, correct?
Yes, ma'am.
So therefore, 3b minus a by b is rational. Because it's made up of integers, then it should be rational.
Yes, ma'am.
This means root 5 is rational because it's an equality. Equality means both the sides are equal. We don't know about now this root 5. We are not talking about root 5. On the left hand side, we have 3b minus a by b. Now we know that a, b and 3 are integers. So that means 3b minus a by b is rational because it's made up of integers. So on one side, if you have a rational, other side also should be a rational. This means root 5 is rational. But we know that root 5 is irrational. No, it's like a theorem. We know that root 5 is irrational. So this means root 5 is rational. This is not true. So this is a contradiction. This is a contradiction. And this is because of our incorrect assumption that 3 minus root 5 is rational, correct?
Yes, ma'am.
Therefore, 3 minus root 5 is irrational. We know root 5 is irrational. So it's a contradiction. And that's because of our incorrect assumption. Therefore, 3 minus root 5 is irrational. The other way of doing it is 3 minus root 5. You can also use the facts related to rational numbers. The facts related to rational numbers. We know that the sum difference, we know that the sum difference, product and quotient of two rationals is always rational. Two rationals is always rational. That is when you have two rationals and you add them, you add, you subtract. Chill in just a minute, I'm getting a call, just a minute. Yeah. Yeah, so we know that the sum difference product quotient of two rationals is always rational, is always a rational. Using rationals, you cannot get an irrational value. Except for division by zero, I don't have to mention that. One is an integer, zero is an integer, but the division by zero is not defined. So I'm not mentioning the exception. Only this is an exception. Division by zero is an exception. Otherwise, when you consider two rational numbers or two integers, rationals or integers, there's some difference product quotient is always rational. So you can also prove by this fact. So 3 minus root 5. Okay. You're adding minus 3, or you can subtract 3, whatever. You can subtract. Now we are assuming the opposite. If possible, let this be rational. If possible, let this one be rational. Okay, if possible, let it be rational. Now, this is rational. By our assumption, this is rational. So this is rational by our assumption. We know that this is a rational number. And the difference of two rationals should be a rational. What are we getting? 3 and minus 3 will get cancelled and you're getting minus 5. But by the theorem, you know that root 5 is irrational. The difference of two rationals, you must get a rational. But what are you getting? You're getting root 5 minus root 5, which is irrational. If root 5 is irrational, then minus root 5 is also irrational. So it's not satisfying that fact. The difference of two rationals must produce a rational. But we are getting root 5 or minus root 5, which is irrational. So again, this is not true. No, this is a contradiction. The difference of two rationals, you must get a rational value. But what are you getting? You're getting an irrational value. This is a contradiction, and this is because of our incorrect assumption that 3 minus root 5 is rational, and therefore it is irrational. How will you show that root 3 plus root 5 is irrational? I think I have a presentation. I'll just show you that. Similar, not the same, similar. So here what you should do is you should take one of it to the other side and square on both the sides. If possible and all that. Take one of it. Take either root 3 or root 2 to the other side. Root 2 plus root 3 is equal to a by b because we are assuming it to be a rational. If possible, let it be rational. After this, you should take one of it to the other side, either root 3 or root 2, and square on both the sides. Now you can see when you square on both the sides, when you started, you had root 2 and root 3. Now when you square on both the sides, you have only root 3. So it's easy to prove now. So now you should continue working, and you should make sure that you have only root 3 on one side and the integers on the other side. Then it's easy to like argue with your statements. If possible, let this be rational. So that means it's equal to a by b. Okay. Transpose either root 3 or root 2. So I've taken root 3 to the other side. Then you should square on both sides. The importance of squaring is, you can see in the next step, you have only one irrational, that is root 3. So now you should take the LCM, cross multiply, simplifying like terms and all that. Finally, you must have root 3 alone on one side and all the others on the other side. Now you will say that this is rational because it's made up of a, b, and 2. That means this is also rational. But we know it is irrational. But root 3 is irrational, we know. So this is a contradiction. And that is due to the incorrect assumption. Now you will ask me, what if we square as it is? Root 2 plus root 3, the whole square is equal to a square by b square. As it is if you square. As it is if you square, you will get a square 2 plus b square 3 plus 2ab. 2ab is 2 into root 2 into root 3, root 6 is equal to a square by b square. Now the difficulty is we don't know. We know that root 6 is irrational, but we don't know that as a theorem. We have only proved that like root p, where p is a prime number, is irrational. Theorems root 2, root 3, root 5, root 7, root 11. We only have proofs for our theorems for. We have proved that root p is irrational where p is a prime number. Where p is a prime number. So here, you can have root 6 on one side and all the others on the other side, but you cannot say that, but we know that root 6 is irrational, but then as a theorem, we don't know. That's the reason why you should not square it as it is. You should not get root 6 or root 10. No, that's why we transpose one of it to the other side. So then you will get either root 2 or root 3 and things like that. And it's easy to say root 3 is irrational by the theorem. Am I clear, children?
Yes, ma'am.
Okay.
Yes.
All right, children. I think if I have anything more interesting to share, maybe I'll share the pictures on WhatsApp. It's time, so you should also stop studying by the end of the day. Like don't make it too much because you should not get saturated by the exam tomorrow. So all that I can say is just stay cool. With a cool mind, you can even answer something which you don't know. Honestly, getting worried about something, don't evaluate your result. Don't see the whole paper and then tell yourself, I don't know this, I don't know this. All those negative thoughts, will just put off your mood. And see, I'll tell you, no exam can tell you what you really are and what your strength is really. All of us are good. All of us have some great strengths. Ahead, all of us are going to settle down in life in a very beautiful way. This exam is just a passing cloud. It's just a passing cloud. When you step into 11th standard, the marks you score in 10th hardly matters. And ahead in an interview, in these days, in an interview, nobody is going to ask you how much you scored in maths in 10th standard, how much you scored in 12th standard. No. Today, your personality, how well you can cooperate with your co-workers. Your emotional intelligence is more important. So how you can socialize. So supposing you're a leader of a team, how well you can handle the team. That is very important. So a person who's got 99% in his professional degree may not know how to handle a team. But a person who's got 50% in his professional degree, your BE or BTech or whatever you pursue, you might have just scored 50%, but you know how to, handle a group of people. So there you will be the winner. Your marks card simply has some numbers on a paper. Build your personality. So don't become weak when you see a set of questions which you cannot handle. Build your personality, and that is very important for the future. Go with good values. Respect parents, respect your elders. Build your part. So even as you go up the ladder of education, you should become better and better as a person, and that is what is going to take you to greater heights in future. Today's world, your marks card, I'm not saying don't study, don't pay. No, you do your best, but in the examination hall, don't evaluate your marks. Don't flip the pages of the question paper and say, oh, I know this, I don't know this, or I'm losing 10 marks. It's okay. Answer the remaining well. It's decided you're going to lose 10 marks. Lose it. At least the remaining marks you can, with a cool head, you can answer that correctly and come out as a winner. Than getting tensed and messing up the remaining questions also, which you know. Understand this. So this is all I can say. Build your personality. Control anger. Learn anger management. So learn such virtues which will be very helpful for you in your workplace. In your workplace, your marks matter, but not to that extent as your personality. So with a good personality, with good virtues, you can always emerge as a winner when compared to a person who studied very well and has a very good academic record. People who lose and then win will also be okay with losing. But people who have always been winners, always getting the highest mark in academics, they'll not know how to handle themselves as a loser. So it's okay if we lose sometime. We lose, we win one day. So we know how to handle both. But if you're always winning, you don't know how to handle when you lose a situation. So work on your personality. You can take up classes, some short-term classes which teach you how to handle anger, how to talk in public. Build all this along with your academic record. So with this, we'll wind up the session, and though we do not have all of us at the end of the meeting, I understand, you will have your own, routine for today, because tomorrow being your math exam, you have a lot of things to revise again. Anyways, thanks Ram, Tarun and Subbalakshmi for staying back till the end of today's meeting. It was really nice having all of you in this class, and really I'm emotional at this point, that we can chat on WhatsApp, or you can drop into my residence. We can meet like that in future. So stay in touch. It's hard to depart like this every year. I have a bunch of students who come to me trusting my classroom, and this day when we have to depart, I really feel bad. It's really emotional, but we have to, right? You have to move on. I have to move on. Yeah, so stay in touch. Let me know about your results, and where you pursue your 11th standard and what stream you have taken. So always make good decisions. Don't go with what your friends are doing. Choose a course that aligns with your personality. Don't take up science because the world is doing science. Okay, so don't be carried away by others. You see your strength and you win in the area where you have the biggest strength. Every field of academics is, great. Nothing is less, but in today's world, people only feel that science is the best course to do. There are so many areas of academics which is untouched. Nobody studies that. Every area is important. So don't do something blindly because everybody is doing that. Judge your personality. There are some, career counseling, academies also. You can get in touch with them. They'll judge your personality. You should choose a course that aligns with your personality. So if you want to do medicine, just think of the life of a doctor and see if you're ready for that. Think of a life of a doctor and see if you're ready for that. Today we see so many engineers, they quit their profession and they start doing something else. They start a restaurant or they, continue, they pursue their passion, photography, or they become YouTubers. They're becoming Instagram influencers. Because they just study like that, they just did their engineering. They're not interested. So then they feel, no, my passion is this, so let me do this. So if your passion is business, you can do your BBA and MBA. If you do your MBA from a renowned university, yes, you can settle down well. Don't unnecessarily stress yourself. BE and BTech, MBBS is not the destination. I'm not saying don't do, but that is not the destination. Maybe that is not for you. So think what you are, who you are, what your interest is. Is science interesting for me? Or should I take up commerce? That's totally new. And it's easier than science. You can understand what you're studying. So with that also, with BBA, MBA also, you have a great career. So please sit back and think what you have to do. Simply don't do because you're good in science, give your NEET exam, become a doctor, and then you don't like the life of a doctor. You cannot live your life like that. You cannot do something which you're not passionate about for the rest of your life. You take up a job, you don't like your job, but you have to do that for the rest of your life. No, you will quit one day. So think rationally. Select a course that aligns with your personality, that aligns with your passion. If you don't know what to do, talk to some career counselors and find your right path. That's very important. All right, children, nice talking to you. Thank you, Ram. Thank you, Tarun. Thank you, Subbalakshmi. Good luck for your exam. Text me tomorrow. All right?
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank
Thank you,
you.
children. Thank you, children. You may leave the call. Thank you.